All right, welcome to this practice calculation. We're looking at question number 2. This comes from the summer administration, so the May-June 2018 question paper 12, question number 2. If you wanted to queue up that paper and follow along. It reads, the drag coefficient, C sub D, is a number with no units. It is used to compare the drag on different cars at different speeds. C sub D is given by the equation C sub D equals 2F over V to the nth power times rho times A, where F is the drag force on the car, rho is the density of the air, A is the cross-sectional area of the car, and V is the speed of the car. What is the value of N? Writing tool handy over here. So the first thing is to sort of look at the left side and they tell us that this has no unit. So it's just like a dimensionless coefficient. So our job will be to make N whatever it should be to cancel everything out over on the right side. So nothing on the left equals what over here on the right? Well, force is measured in newtons, but we know that a newton is a kilogram meter per second squared. So I'm going to use the base units for newtons of force, and that's just from this, right? Now in the denominator, I know I have like meters per second, but those are raised to some power, right? It's either going to be 1, 2, 3, or 4. Those are my 4 possible choices. So I'm going to kind of like leave those as like question mark Mario boxes, and we'll fill them in as we need to. Now, what is density? Rho equals mass per volume. Density is like how much matter can we cram into a given unit of space. So black holes, pretty dense. They've got, you know, stars worth of mass occupying really, really tiny volumes. So a pretty dense object like black holes or neutron stars. Helium balloons, not too much mass, you know, pretty appreciable volume. So they're very low in density. Okay. Water has a density of 1,000 kilograms per cubic meter. But how convenient. And that's because the original definition of the kilogram was based on a certain aliquot of water. So that's the density of water, 1,000 kilograms per cubic meter. Imagine building a cube out of meter sticks, making it watertight and filling it with water. 1,000 kilograms would fill that, you know, cube of water. Remember what 1 kilogram is, my weight, you know, that I showed you the other week. So that gives it away. Those are the units of density, right? Kilograms of mass per cubic meter of volume. And so that's in the denominator. So we're going to have kilograms per cubic meter. See how I plug that in? Because it's in the denominator, very similar to last week. Like when you plug it in, it's the denominator of the denominator, right? Going back to the numerator. So that's from the density. This is from my velocity. This is from my force, right? Just so you can kind of keep track of that. These units come from force. I'm just going to combine it all and just fill in what I need to here to make it all work, right? What's area? Length times width. So the units would be meters squared, right? So from my area, I get meters squared down here in the denominator where it is. So maybe this is a helpful way to like, you know, but this is like the third calculation we've kind of done like this. And if by the third calculation, you're like, I'm starting to kind of get it now. Yeah, I see how this is not so bad once you get to know it. I hated it last week, but you know, it's not so bad. Or if you're like, no, I still hate it. It's terrible. Alphabet soup for breakfast. Awful. Kilograms are going to cancel, right? These meters are going to cancel. So we're left with a meter up here. Oh, no. We got meters to the 4th power, right? This meter and these. So we got meters to the 4th. So 2 of them will cancel. So we have meters squared up here. And then we have seconds squared down here. So what does this have to be to cancel out everything? Does everybody see this? How the kilograms are going to cancel already. These meters will combine with this to give us meters to the 4th. And so like those 2 go away. And that one goes away. And like that's really like a 2. And so what are we left with? Meters squared per second squared. So what does the coefficient, what does the exponent need to be on this velocity? Well, if this were a 2 and that were a 2, perfect, right? Then those would cancel, then those would cancel, and we'd have dimensionless, like we have no units. So the correct answer is 2, right? E would equal 2. That's 1 out of 40 questions on this paper 1. Paper 1 is multiple choice. You get 1 hour and 15 minutes, 75 minutes to answer 40 questions. So that calculation has to be pretty forthcoming. Okay, when you're sitting for paper one. Who has questions about this? Did I lose anybody anywhere along the way? Yes. Not yet. You have to have a growth mindset. Does the power of yet, like we're not taking it yet, but one day. Not with this course. There's no ACE paper associated with pre-ACE physics. All right, so that's been another worked example with Dr. Schleich. We'll see you next time.